Hello and welcome to the Welding Tips and Tricks podcast. I'm Jonathan Lewis, here with Roy Crumbrine.
Hello.
And Jody Collier.
Hello.
Today we're going to have Scott and Josh from Micro Arc Welding on as our guests.
If you look them up on Instagram, it's Micro Arc Welder. They specialize in mold repair, which means they weld on all kinds of high-end alloys using micro TIG down as low as a tenth of an amp start amperage. And they use laser as well as just TIG welding. So they just do all kinds of stuff on all kinds of alloys.
What's your full name, Scott?
Well, Scott Malcasian, Micro Arc Welding. And I got my nephew here, Josh, that is coming up the ranks here, and Josh Immer. And, we've been welding since 1983 and business since 1988. And been... found a niche in micro welding.
Awesome.
Very, very interesting. We've all followed the page from time to time. I'm on it right now I'm refreshing my memory on stuff. But it's like, it would seem from looking at what you guys do that, you do some tool and die, some mold repair and precision stuff, but then also some regular, maybe some turntable type TIG welds on stainless steel and things like that. But all of it looks like super high-end stuff. A lot of skill represented here.
It's always good finding a niche, and all these industries are going automated, CNC, kind of hands-off, close the doors and push the go button, and the thing does its welding. But there's really just no substitute for the human eye and the human hand. There are so many projects that you just simply cannot automate. And we really fill that niche. I mean, we weld down to 3,000ths welding wire. Our everyday wire is 10, 15 thousandths. And, it's all tool steel. I mean, we've been welding high alloyed, high carbon content tool steel for almost, 30 years now. And, we work on basically our biggest client has been the tool and die industry. And we're working on high-end plastic injection mold components, cavities, and cores. Some of these blocks are $10,000, $20,000, $30,000 a piece. And they're all finished within literally tenths. They're all hardened, 55, 65 Rockwell, depending on what type of tool steel it is. Now, we got to go in and weld it without destroying it and try to fix it when the human factor comes in. When the mold is being built, there's machining mistakes that are made. There's design changes. Sometimes you get a plastic cap on a detergent bottle or something that's not snapping right, so they have to redesign the closure of that. So a lot of times it has to be welded. There's mistakes on these molds that are made in process. You get a part that sticks in the mold, and some guy on the night shift is in there with a screwdriver trying to get the thing out. So there's all kinds of different reasons why a mold component has to be repaired. And it's way, way cheaper than to weld up the area in question than to, you can't go out and make a whole new mold. It's just not feasible.
Mm-hmm. Sure. I know enough about molds and tool and die repair and laser just enough to be dangerous. I got a taste of all that stuff here and there. I've done some manual TIG repair on some in injection molds, and I got a taste of laser welding and build up and how that all works. My last year at the airline that I worked, the engineering department, had like a extra $100,000 in their budget, and they had a day to spend it, and they just bought a laser. So I was lucky enough to get to play with it and sort of like qualify some parameters and mess around a little bit like that. So, but I'm no expert. I just know enough to be dangerous. But this should be a very interesting conversation because some of the stuff you were saying is exactly what I've experienced. It's like you got a $20,000 mold. It's, say it's D6 or some kind of other really hardened steel, and night shift took a chisel or a screwdriver and a hammer to pry it apart, and they dinged a little area. Now it's getting too much flash, and the mold's not coming out right. And little bit of well-placed weld is worth a lot of money because usually that mold is on a line that is now not producing what it's supposed to produce, and they want it back as quickly as possible. So, like you said, finding that niche is a really big thing because now you're not working for $10 an hour. They're willing to pay good money to get that thing back up and running.
Oh yeah, yeah. We do well down here because we get work coming in from California. Almost every state in the country, we get work being shipped in. They literally will ship it in, red label, onto our loading dock at say around 10 o'clock. They want it welded and shipped out, red label that afternoon. There's so many days that we're rushing. We got FedEx down the street, not too far from here, that we're 7:30 is the cutoff, and we're just getting there. But some days before they close, so it's like it's a crazy business. I'm here. I'm 57 now, but I'm still here 9, 10, 11 o'clock at night. A lot of nights I have customers come in at 5:30. I got to have this back in the morning. The mold is down. We're not producing any parts. And I say, yep, bring it in. I always say yes. I don't push that on my employees. I'll take that burden, but it's what you got to do to have a successful business.
It kind of is. It kind of is. You can't just be fat and happy and be like, yeah, we'll get to it when we get to it. When they're losing however many $1,000s a day in production, in parts. So
exactly.
I mean, they don't want to hear like I'll get to it when I get to it because, man, they say, what'll it take to get it done? I was just working with my friend JD today. I wasn't working. I was just holding the camera. He was doing all the work. We were hanging an aluminum awning frame at a blow mold factory, and they make bottles for all kinds of products, spray bottles for like chocolate milk and things like that, and so that's just a good example, man. If something goes down, I mean, that just, it's like their money machine it stops, if something goes down because of a mold needs repair. So, I feel you. It's like hard. You can't say no, that's what business you're in.
Exactly. We're in that business. I mean, you just got to do it because if you're in the wrong business, if you can't act like that, because the customer won't stick with you long if you can't turn the work around quickly.
Right.
So, like we work for one of our customers is a major a firearms manufacturer. The frames are composite plastic frames of the most handguns are nowadays, and severe amount of weld on. They wanted to change all the texture on the grips, and it was just a lot of weld on this one thing. So you have to do your preheats. I'll weld an inch on the area. I'll peen the weld, with a carbide peen and a hammer. Weld a little more, peen it, because, you can start curling a block or cracking. Cracking is the biggest thing, welding high alloy tool steels. The block can be done sitting on the bench, and all of a sudden you hear this ding. It's like, oh, what the hell was that?
Never want to hear that.
Oh, that is the worst thing. I mean, there are so many challenges in that. I mean, even I've welded jobs where it was A2, and and usually it's not a good welding material. But sometimes it'll weld okay, and the next job you just touch it and it'll crack. And it depends on how it was tempered after it was heat treated, and you don't know that. There's so many unknowns when you grab a block like that. What has this block been through before I've seen it? Has any other welder got a hold of it? What's the tempering temperature has been done? And we deal with a tremendous amount of, geometry problems, where you're welding down inside a pocket and there's a sharp corner next to a rib. And right off the bat, I look at it and say, okay, the weld's going to pull. It's going to affect this other detail. And then, you got to find a way to stop that weld where you're not creating this domino effect. Sometimes I'm welding near a corner, but because of the type of alloy it is, I know if I weld near the corner, the pulling action of the weld is going to crack it right in the corner. So I will actually weld the corner first and go in there maybe with a 300 series, something a little malleable, and then start my tool steel welding where it needs to be. You've got to really study the geometry of what you're welding. And remember, some of this stuff is, 55, 60 Rockwell and doesn't want to bend. It wants to crack.
As hard as Japanese arithmetic.
Yep.
Yeah, man, that is some. I tell you, it's just one of those things that it just speaks even further to the nichiness of what you do, because how many guys can predict what something at 55 Rockwell is going to do to the geometry and the weld placement and all that stuff. It only comes with experience, and it's just not anything you're going to read in a book anywhere.
No, and one of the things that we're known for too is getting into really tight areas. Like we'll have a blind pocket, 30 thousandths wide, half-inch long and a half-inch deep, and have to weld something, a DC arc from the EDM process, or in the bottom, or the electrode that burned that pocket didn't have the right radiuses on it. So we have to go up and weld the corners, and we have to get the tungsten and the wire and everything down into a half-inch slot that's only 30 thousandths wide. And literally you can't even see it sometimes because, we weld under a microscope. The microscope's tipped on an angle, your one eye is closed and you're squinting, and there can't be any weld sync. There can't be anything. It has to be perfect because any type of imperfection around the weld will show up in the plastic.
Yeah.
Mm-hmm.
Or cause an undercut where the mold will not eject.
Yeah.
Because there's an undercut and the plastic is going into that undercut. Plastic will flash. Most plastics will flash at 7/10. We cannot have any weld sync, greater than 7/10.
Let that sink in for a little while.
Yeah. So we have a big granite inspection plate. We have 10th indicators. We'll be welding a parting line of a part, and we'll get in there with the 10th indicator later, and we'll bring it right up to the corner because any little tiny imperfection, the plastic will go in there, and it'll get rejected. It's crazy. I mean, the most people's splatter is bigger than our purposeful welds.
Oh yeah, I believe that.
Well, what percentage of what you guys do is TIG versus laser versus whatever else you do?
Well, I mean, over the years since I've just been here, when I first started working here, it was transferring over more into the laser and more, and less TIG, and customers requesting laser. So it's crazy, and it seems now almost like it's 80% laser, when it comes to the tool and die repair. Anyway,
you're talking about preheat a little bit earlier. Does the preheat requirements, change? Are they eliminated by using laser, or do you still preheat using laser? And how does that all play in there?
Well, they say that you don't need to preheat when you're using laser, but as we all know, there's some bad stuff in cold steel. Mm-hmm. Moisture, hydrogen, and so we don't preheat as intensely as we do with the TIG, but we do preheat. And I think, we're always learning. When you stop learning, your minds will be dead. So, we're depending on the type of project, depending on the type of alloy, we'll do full preheats even with the laser.
Yep.
Mm-hmm.
Because laser is I have always said this from the beginning, laser is another tool for the toolbox. It will not replace TIG, and TIG will not replace laser.
Yep.
Mm-hmm.
Because, you can't, we have a 325 watt YAG laser, two of them, $250,000 each. That was another thing we had to get into, going from, TIG machines to, which we thought were expensive at the time. And now all of a sudden we have to start getting into lasers, but you have to, because that's where the industry is going.
Mm-hmm.
Right.
And, and laser isn't meant for big buildups. You're not going to do big buildups with laser. 20 thousandths wire is about all, 25,000.
That's big wire. That's big wire for a laser, isn't it?
Yeah, I mean, our go-to wire, well, we go anywhere from 3 thousandths up to, 15 thousandths. We go up to 25 thousandths. But
just to put it in perspective for people that are listening here that may not, the 3 thousandths may not register. I think that's a little smaller than a human hair.
Yeah, pretty much. Yep, pretty much.
Roughly, that's equal or so. Very, very similar to the size of a human hair. So that's right. How do you hold that steady and put a little bit of pressure and flex on it?
It's
crazy.
Not easy. I mean, when we're using that type of wire with the TIG, we literally hold a 2 to 3 thousandths tungsten to puddle gap. So our tungsten tip, when I'm welding TIG, micro TIG under the scope, I have probably about a 3,000ths gap or less.
Jeez.
Because
I thought I held a tight arc.
Yeah, you do.
Wow,
but
yeah, you do.
2,000s.
You do, Roy. Come on.
Yeah.
But
2,000ths that's a tight gap.
That's impressive.
while the puddle is moving, and maintaining that type of gap, because when we absolutely need that pinpoint heat spot, because the heat starts to transfer out too far. We're trying to get into tight little corners, and we're wetting the arc out without creating knit marks. The tool and die industry is mainly cosmetic welding, if you want to call it that. We're not fabricating. So
right.
it's cosmetic type welding.
Mm-hmm.
And so the cosmetic part of it is the important part of it. I mean, it has to be perfect. I mean, we weld some medical parts for molds and things, and even brushing the part with we use these very fine stainless steel brushes, that will, if it gets a little soot or gets a little something on it, we'll brush it. We have to be careful even with that, because we can start rounding over corners on a medical part or a certain part. We can wreck it just with a little fine wire brush.
Really?
So the detail is just mind-boggling when you really get to know what tool and die welding is all about.
Yeah. I'm curious, because you just mentioned welding under using a stereoscope and whatnot. To what power source are you generally using, and what amperages are you using in your tungsten diameter and all that stuff? I wonder if you can clue the audience in on some of that a little bit.
We basically use a 16th tungsten. It can handle in our power source will go up to 100 amps. It has a dual range power source from 1/10 of 1 amp to 10 amps, and from 1 amp to 100 amps. But it has a 70 amp continuous duty cycle, but it will weld up to 100 amps for a short amount of time.
Okay.
And when we start an arc, we can have that. Like, I just bought a Dynasty 400.
I saw that.
Yeah, and we just set it up last week. This is because we do some big stuff too. We don't use this for micro welding,
mm-hmm.
but it has a very nice. Once you get the arc started, it comes down low very nicely for what we do. But when the arc starts, you have it's like a 5 amp surge.
Mm-hmm.
And that's actually too much for what we do. So I might see if I can get somebody from Miller to see if they can tweak that for us. But yeah, we use 16th a lot. I mean, we use 40,000 stuff, but 40,000s can't handle the amps, because when you weld a plastic injection mold, there's times in that one weld where you need 3 amps, and there's times when you need 80 amps.
Mm-hmm.
So I can't be switching back and forth from 40,000ths tungsten to a 16th tungsten. The 16th seems to work fine, because it can handle up to 100 amps without the heat getting diffused. Too much.
Do you do any special like tip prep? Do you do any special prep for it, or just straight up tungsten grinder, or you just use a sander, or you polish it, or anything special there on the 1/16th electrode?
Well, we hollow grind it by hand to a. There's all kinds of tungsten grinders out there, but I've never bought one. But we hollow grind on a slight angle on diamond wheel to a very, very sharp point.
Probably like a 25 degree or something like that angle.
Yeah. It's been 30 years, and I said, okay, that looks good. And that's. I don't even know, but it works for us. But I can't tell you exactly what angle it is.
I understand. I don't know that any of us. Actually, I have a diamond wheel grinder, but I didn't buy it. It's just because somebody sent it to me in the hopes that I would show it in videos and stuff. But I don't think I ever could pony up that kind of money when there's other stuff that I want. It's just I think by hand, is you can do a lot by hand.
Well, we have those NSK grinders, and I have a pile of them. Some of them are old, some are new, but I have an older one that we use. We put it right in the collet of the NSK grinder, the handpiece, and we use that to turn it, while it goes against the diamond wheel.
Okay.
So I used to just turn by hand because, back in the old days when I first started, there was no small diameter wire to buy. I used to centerless grind because I was a tool maker in my dad's mold shop right out of high school, and he had an old centerless grinding machine. And you could not buy, the smallest tool steel wire you could buy was probably 45 thousandths, maybe. And that's like a telephone pole in our business. It's humongous. So I used to centerless grind it down to 15 or 20. And, before it exploded. And I didn't have a microscope. I had an old Airco welder, an orange. Remember those old orange Airco welders?
I do.
Didn't have a microscope. I had this little thing that looked like a little pencil with a little spyglass. So, and I had it. So I used to weld it with a helmet, and then I used to look at it with my little spyglass and see if I welded what I was supposed to weld. Sitting on a metal stool. So,
come a long way.
It was crazy. It was crazy. Yeah, and now we have $250,000 laser welders.
Wow.
And I need another one. I got 2 of those, and now I need another one.
One thing I noticed when I got a little taste of the laser welding, and they're awesome. They do, an awesome job, and they definitely have their place. But like we were just like qualifying some parameters, and so we would run some beads, and then we would section them, and then we would cut, polish, etch, and like we would be looking for spot overlap and things like that, and just running beads. But you could, even at that low intense but low heat input on a piece of maybe say just a little small coupon, 20 or 30 thousandths thick Inconel 718, one bead you would see some deflection because so much, I guess you would call it gradient of heat. It's a cold piece and you're popping that thing and then shrinking, it's solidifying immediately. But even though it was not putting a lot of heat and stuff in there, there was definitely some residual stress because it was bowing that little coupon up with just one tiny little bead, across there. So, that's just something I observed with the testing we were doing.
Really?
And, yeah.
Because I don't find that.
Maybe we were doing it wrong. We were noobs, we were just like, we got a laser, let's weld some stuff,
Yeah. I mean, we'll weld, a lot of molds have thin blade inserts and stuff, removable inserts for different reasons. And sometimes the blade will be literally 40 thousandths thick, and we have to weld one side of it because there's a detail missing or there's skive marks in it from running in and out of the mold pocket. And I don't know. The laser definitely has less thermal distortion than TIG welding. And it all depends on your settings too. The milliseconds, comparison to your volts and your spot size and the hertz too. What kind of hertz you're using. Our welders they'll go up to 100 hertz, which is almost a constant bead. But we typically weld at 10 hertz around that area. Depending on the project. But yeah, it's really. I don't know. It's an amazing tool. I mean, I started with an old Rofin laser. It was a jewelry laser because back when I first started in this with the laser, Trump had one at the time, but the lasers for the tool and die was really just coming out. So I had a Rofin jewelry laser that I modified to do tool and die. And actually that was a good machine for years, but then it's like, okay, you got to step up to the big machines, and then at that time when I got done with the Rofin was at its life expectancy, there was other manufacturers now coming out with some good, lasers made for the tool and die industry, and that type. And I went all over the world finding the one that I wanted. And, they're not all created the same. Right. They're not all created equal. You can get completely different weld characteristics from one manufacturer to the next.
I tell you, when you're looking at a $250,000 piece of equipment, you can run into some sales BS. You really got to have your BS radar up.
Oh yeah.
Up, His sales guy is going to try to tell you this thing's going to. Yeah.
I got a story a short story if you're interested.
Bring it on.
I'm not going to name any manufacturers, but there was a laser welder that, one of the ones I was trying, and I tried it at one of the trade shows. It was years ago, and this is before I knew a lot about the laser welding. This is after the Rofin thing when I was in the market for a new one. During the trade show, I overheated it at the trade show. So it's like, okay, well, So then they brought one, the same company brought one to my shop, overheated it again there, and then I went and tried the same one at a company that they had one in their shop. They were trying it out. So they let me come in when the reps came in, and I was welding I was testing it on some beryllium copper, because we weld a lot of beryllium copper too. And I blew the resonator out of it. It was a $10,000 mistake.
Oops.
But I was on the phone with the factory at the time, and I don't know, keep going. And it had a lot of great features. It's almost like having a Ferrari with a Yugo engine in it. And the thing is, it couldn't weld 25 thousandths wire because the focal point between the top of the wire and the bottom of the wire was too great, because laser welders are all about focus. And some of them they call it the sweet spot. It comes down like a cone, comes to a center, and starts going out the other way. At the transition point, at the focal point, some laser manufacturers, they call it the sweet spot, where it's more forgiving with focus. So, but this other one, it had a sharp V going right into the next V. So the distance between the top of the wire and the bottom of the wire was too great. It couldn't weld it. So that's one of the things that, somebody, I want to go buy a laser. It had tremendous features on it. It had a lot of great features. But the resonator in the machine was a piece of crap. And so after because the Rofin was actually, even though it was a little glove box laser, it had great weld characteristics. So I knew what I was looking for. And I thought, all lasers must be this way. But come to find out they're not. So I was in Germany. I was all over the place finding, the right machine for me.
Yeah. A lot of skin in the game. When you're talking about writing a check for $250,000, you don't want to get something that, has too narrow of a focal point. You kind of bought a pig in a poke then for what you do. If that's the case. So.
Yep. Yeah. I thought, geez, I could have bought a nice little house in Florida for this. I'm going,
Really? Yeah. We had it was a Trump model. I don't know the exact model number. We had a guy, I want to say his name was Steve, that he used to be a Trump employee, and he came and he did a little training. It was just very interesting little, couple of days there learning that thing, but I got away from it and didn't really spend a lot of time on it. But I could see, it's kind of like, man, it's just like anything else. It's an acquired skill of just being able to hold the wire with the right tension and, put it in the right place. And you're looking through the stereoscope like you're looking at crosshairs. And then you got the little Pac-Man joystick, and you got to have all of that stuff in your mind as far as your spot size, your settings, the frequency, the hertz and all that. But man, once you got it dialed in, you could go to town.
Right. And, a lot of times at these trade shows, they'll have a flat piece of steel and they'll have you laying, flat lateral beads with the laser. Oh, look how simple it is. But now you start applying that to a three-dimensional tool and die component in the real world, everything changes.
Right.
Because you have, laser deflection. You're trying to weld a sidewall of something.
That's its own topic right there.
Yeah.
Deflection.
So laser deflection. That laser will bounce off one surface, hit another surface that you don't want to weld, and you can cause more damage than, trying to help. So everything has to be. There's been jobs where I've welded the whole job, and because of the geometry of the part, I couldn't see what was going on until I flipped it over. I see this whole other surface was melted from the deflection of the surface I was melting. And it's like, oh, you gotta be kidding me.
Yeah.
So it's, but Josh here, he's really coming up well in the welding, and he, you can tell he loves it. And, he worked at the tool and die shop too, the same one I did for a while, for my brothers. After my dad died, my brothers took over, and he was out there for a while being a machinist. And, so he's come up similar to the way I did, because you can't the tool and die business is very technical. You have to understand how molds work, what's important, what's not important to do it right. I always try to think like the machinist thinks, because, it's like, okay, what does the machinist have to do to this after he gets it back from the welders? If I can avoid getting weld on this other surface, that will save the company a whole pile of time if they have to wire EDM a pocket out or make electrodes for something they don't have, because I got weld onto a surface that was close to a surface but didn't really need to go over it. You know what I mean? Mm-hmm. So I always try to put myself into the shoes of the machinist, the tool maker, and say, what does he has to do? And it can go the other way too. You can be welding, trying to keep off this one surface with your weld, but it's like, geez, if I get weld on this other surface, it's a simple flat grind, and it can save me hours of my time if I incorporate this other surface into my weld. But it ends up being a simple fix if I do. Put it on the grinder, and they grind it off in 10 minutes, where it took me 3 hours to try to stay off of it. So it can go both ways, But you really need to understand molds and how they work in order to service that industry properly.
Roy has made the comment that some of the best advice he received early on in his welding, in his formative years, was to adopt a machinist mindset, and just paying attention to details and everything. But what you're saying is it's taking it a little step further and putting yourself in the machinist's shoes, and where you're putting you're putting down stuff. If you're putting down stuff in the 55 to 60 Rockwell range, that ain't coming off easily, unless it's on a flat surface where they can just do a straight grind on it, like you said, piece of cake,
Exactly.
Yeah. So, but yeah, we're getting down into the nichiness of the niche that you have carved. That's the kind of stuff that people don't know, and then you only get that from experience.
I just thought if we were featured in a new magazine, a new hard-covered book came out from McGraw-Hill, Design for Advanced Manufacturing. And they called us for an article, so that was pretty neat. They talk about all kinds of different things in this book, but it was pretty neat being part of that.
Yeah,
that's cool.
Always nice being recognized as a sort of an industry insider, influencer, leader, whatever you want to call it. That's always nice.
Yeah, because most shops are that do what we do. They're all pretty much run by one person. So a lot of shops like mine, there's not many. There's only a few of us around the country really that are good, and they're all one-man shops. So I've been trying to, 3, 4 welders and stuff at a time. And it's tough because when you're training somebody, you can get them to a certain point, and then they just can't get to that micro level. Just feeding, 10 thousandths wire. They can't get it into the puddle without it balling up or sticking tungsten because they have to, it's just very, very, very tedious work. You gotta be able to love that type of. I'll spend an hour in a little thing, an area that's as big as my thumb. Just down inside of pockets, around core pins, sidewalls. We do a lot of work for a company that makes razors and all that stuff. Very, very detailed things. The job I just laser welded a little while ago, it was like I spent 3 hours on this tiny little block. The detail was just tremendous. They had an electrode that was burned. All the detail was burned too deep. So this whole area had to be built up, and it was gaps at 10 thousandths wide between core out areas. And the point I'm making is you just got to love it. You got to love working with your hands and love that type of stuff.
Yeah, it correlates to airline maintenance or aviation maintenance, commercial aviation maintenance, I should say, in the sense that a lot of times we would get, like, say, a aluminum or a magnesium gearbox, and it would have, an area, maybe this is on a much larger scale, but it might have an area the size of your thumb just got knocked out, it's gone, and you got to replace it, or maybe even your fist. To be honest, maybe somebody just got happy with a torque wrench and just busted out the whole oil strainer bore or something, and you're going to build all that back with metal, and you're like, wow, that's going to take forever. Well, guess what? It can take forever because the gearbox costs $200,000.
Right.
So how much you're allowed to spend some time on this thing? Like, if you camp out on it for 2-3 weeks, we're still good.
Yeah, exactly right. Exactly right. And,
but the molds you're talking about, so much machining time and everything has gone into them that it's worth it to spend the time and for them to pay the money that it takes to fix something like that. Not to mention that it's just downtime.
Exactly.
It warrants the effort and the skill and all that goes into it.
Right.
Yeah.
Well, Josh, how did you get started in micro welding field, and just give us your story there?
Well, yeah. Originally, when I was about 13, I'd say I wanted to be like, the Jesse James of welding. I actually didn't even know that Scott was like a welder. Like, I thought he did some sort of machining or something, and my uncle's shop and stuff. And I was into the shows like Monster Garage and what was the other one there? West Coast Choppers.
Mm-hmm.
And I remember going to my mom and being like, I want to weld, like I want to like make stuff out of steel. This is so cool. Like, this has got to be the coolest thing ever. So she goes, she's like, your uncle's a welder. And I'm like, he is? I didn't even know that. I mean, I remember being in his shop when I was a kid and like seeing the microscopes and stuff, but I didn't exactly know what he did. So on I think it was my 14th or 13th birthday. I think it was my 13th birthday, I believe. My mom and dad actually got me a Lincoln. What was it? It was an SP 135T or something like that, MIG welder. And she's like, hey, ask your uncle to show you how to use it, and you could probably, get you to dial that thing in. And I was like, yeah. So I went to the shop, and he was more than happy to show me how to use it. And me and my neighbor got a hold of some, I think it was an old piece of a playground or something. It was like all galvanized and everything. And we were chopping it up, and we're like, we're going to make like a mini chopper. Like, this is going to be the coolest thing ever. We welded this thing together, and it actually took it for a little ride down the road, and we were all done with it. But, it fell apart probably like a week later from what I can remember. But, that's when I knew I was like, that was it. Like, this is what I want to do. Like, I want to weld. And then, the more I communicated with my uncle after that, like holidays and stuff, we'd get together and we'd just start like, talking about welding. And I started realizing how much of a niche and how kind of like special his style of welding was. And it just made me more and more interested. And I'm like, I want to work for you someday, I think. Like, I'd love to learn this. This is amazing. And, he's more than willing to take me under his wing. I'm very grateful for that. So, I worked landscaping for years. Was getting sick of that. And basically talking to my uncle and saying, oh, yeah, if I could get in there someday, that'd be great. And he's like, yeah, as soon as I, some guys might be retiring soon and I can get you in. And so I ended up working at the tool and die shop after, I think I was about, I was like 19 or so, 18 even. And my other uncle, they had a position, and he's like, hey, yeah, if you want to come in and learn some tool and die stuff. And my uncle Scott, who I work for now, he goes, that's good. If you can get in there, you can learn the tool and die trade. He's like, it'll help you a lot if you ever come work for me. So, yeah, I worked there and for...
So I stole them, in other words, from my brothers.
Yeah, I worked.
Poached him.
Yeah.
I poached him, that's right. I poached him.
I worked there for a few years, and there came a time where things were changing. The industry was changing. I actually learned on the Rofen laser. He was doing some little medical parts, and I would come in after work from the tool and die shop, and he'd set me up, and show me how to do it. And, he really spent the time with me. That's the big thing. He really took the time to, break it all down for me, the mentality-wise, and also just in general, just said, hey, after I do it a little bit, you go, how do you feel? Is this something you think you could get into? I mean, can you stare down a scope 8 hours a day and be okay with that? And I was like, hell yeah, this is awesome, And so, yeah, I was doing some side work for a little while, and a position opened up where I could come in. He was getting the work where he could take me in. He offered me the spot and jumped on it.
That's awesome.
Yeah, here I am.
Here you are now.
Yeah, very grateful.
How long has it been now, Josh?
7. I think we're going on 7 years now.
No kidding.
Nice.
Yep.
Yeah, 7 years.
What exactly are you doing when you're using a laser welder? Like, what's the actual functions, and what are your hands and feet doing? And
Well, you got the pedal, your foot pedal, and it's got all levers and switches on it to do your volts, your milliseconds, your hertz, your spot size. Each little lever does one thing, you know what I mean? And then you got your joystick, which is your focus. You know, it moves the head all around, X, Y, Z axis. Rotary, yep. And which controls the chuck, the turning chuck. And basically it all simultaneously can work together if you want it to. You can set it all up and can basically make it kind of work all together, or you can individually sort of do it. I mean, it's automated. It can be automated. A lot of the time, I just use the joystick freehand. If you're doing like a straight line, a straight beat, or like a corner is worn out on something and you want to, sharpen it up and you want to run like a perfectly straight beat on it, I'll set up my X-axis automated, do some dry runs to get it straight and make sure everything's, on point. Because when you're looking down the scope, you got like a crosshair, you know what I mean? And you line things up, and it's weird, it's you can make it automated, but a lot of the time I'm just kind of using the joystick freehand and doing it that way. But
using the laser is really almost completely backwards from TIG welding, because TIG welding, your part, unless it's on a rotary position or something, is stationary, and you're moving. You get your torch in one hand, wire in the other hand, and you're welding your part like that. The laser is the opposite. It's almost like painting a picture where the paintbrush is held in a vise and you're moving the picture around it with the paint on. So it's really completely backwards from TIG welding.
that's weird. So now, whenever we see your videos on Instagram and you're seeing the bead coming down and it kind of goes around a little detail, then comes down again, then goes around another little corner or something, that's all freehand?
that's all freehand. Yep.
Because when we're moving in elevation, we will actually, there's a little knob on the joystick. If you turn it right or left, it'll cause the table or the head to move up and down. When we're tracking an uneven surface, we'll be actually tweaking the knob on that joystick to follow that shape, keeping in focus the whole time.
Yeah.
And we'll actually sometimes purposely come in or out of focus in lieu of going in and changing the settings, depending on what we are. Oh, I need to hit this spot a little harder. Instead of going up and changing the settings, we'll take it out of focus. Going down, taking out of focus will make the beam hit harder because it'll be a little blurry, but because it's coming out of focus. Or if we want to soften it up, we'll take it out of focus coming up, and it'll actually broadens out the beam and makes it a little softer. So we can make small adjustments just in the focus when we're welding something. All freehand.
So you said that the part is moving. Is it on like a chuck on the table, and then the table's moving in X and Y?
On one of our welders, the head moves, and the part is, the block is sitting in a vise on a table. On our other welder, the table moves, X, Y, Z, rotary.
Yeah, and the head stationary.
And the head stationary. Kind of the same thing, but different. It's I mean, these machines are CNC programmable and all this stuff, but with the tool and die, it's very little call for that. But we have, over the last 5 years, have been going into all kinds of other industries, which we didn't really talk about. Medical device, aerospace, defense, fiber optics. The guy making the latest hydrogen fuel cell battery. We're working for companies in New Zealand, in Austria. We'll have tubing, 1 millimeter tubing, thin wall that we have to weld to something else. without getting any weld inclusions into the tube. We'll have these little parts that are literally, 10 of them will sit on the head of a pencil eraser, and they have to be welded to something else perfectly. So we not just tool and die anymore, but we're into all kinds of other industries.
That's pretty cool.
Very much. So I know you went back and you talked about getting started and what years and whatnot, but what made you actually get into laser welding? I mean, what did you think that, oh yeah, let's try this and this is going to be a hit for us?
Let me think. Well, actually, Trump came to me because I was always pretty well known, but Trump came to me with it was a company that was repping Trump, and they had, at the time, it was a pretty fancy welder designed for the tool and die industry. They had it on this truck, and they were going around to mold shops or welders and stuff and selling. So I got a taste of it then. And, and just keeping, going to trade shows and keeping up on the industry, you learn about some things coming up, the next greatest thing. So that kind of, if I'm remembering correctly, this is how I kind of started thinking about, hey, maybe laser welding could be used for the tool and die industry. And I tried some local, the company in Rhode Island that was selling a laser with but they were all like jewelry box lasers. Because in the jewelry industry, the lasers have been around for a long time, but they've never been really made any for the tool and die industry because they didn't really have much of a chamber. The scope, the lens in the lasers were at a fixed angle. They weren't straight down. So because when you're welding jewelry, it was a comfortable working position for that. So that's kind of how I got into it. And then I tried the Trump laser, and I liked it. I ended up modifying the whole thing. I jacked the whole front of the laser up so I would get rid of that angled scope. It was kind of crazy. And I made a big stainless steel work chamber for it. And, there was no table in it, no XYZ table. So I physically had to hold the parts in my fingers and welding wire in one hand and weld that way, and I was doing all kinds of crazy mold jobs, but there was no XYZ table. So it was really, back in the dark ages of tool and die welding with a laser. I didn't get my first, automatic table until I bought one of the big lasers I have now. So I had to really learn from just really, sometimes I would put a little tool maker's vise, in the laser, and I clamp a rail down on one of those medical jacks, that's a little, you turn it, thing goes up and down, and used to slide the part against the rail with a hand trying to lay lateral beads. So it was, that we got into that really from the ground also. With the laser part of it.
Well, it's good that you could forecast and see, this was going to be a thing.
Well, that was the thing. I had no clue. I didn't, I could. They had the Trump laser at the time, which was that had XYZ table and stuff. But it was like a tremendous amount of money, and nobody was laser welding back then. Nobody. So I said, do I want to invest this much money in this piece of equipment and it end up not working out for whatever reason? I really thought that the laser welding would only be about 10% of my business ever. But now it's probably it's the biggest part of my business. That's why I need another laser welder.
Crazy.
So, yeah. And we get calls all the time from people all over the country saying, hey, we got this weird project. It's like, do you think you guys can really do some things with this wire that's a thousandth and a half in diameter and has to be welded to something, or it's just, I say, yeah, no problem, let's bring it down.
Yeah, sure. Sure.
Always say yes first.
Yeah, well, it's kind of like after you've done a couple hundred of things you didn't think you could do, it's not that hard to say yes for the next thing.
Yeah.
How exactly do you feed 3000s wire?
Yeah, good question.
With your fingers.
Because I've tried the 15,000s and had a pretty hard time with it. I ended up buying a little pin vise and just would stick it out and dab it in and pull it out a little bit more.
We do a little of that too, but the you can't have when you feed 3,000ths wire or 5,000ths wire. It's not sticking out from your fingers very far.
No.
Maybe an eighth of an inch. 3/16 of an inch, because that's all you can do. It's so wispy. It's even hard to get it back into the tube that you took it out of.
I would lose it in the tube.
It's all curled up. It's a mess. You gotta trying to get it out of the tube. You gotta straighten it out because it's just so fragile. And a lot of that 3,000ths wire is actually centerless ground.
Jeez. Started off as an eighth of an inch.
Because that was the biggest part of drawing tool steel wire down to small diameters, is that it would work harden in the drawing process and become brittle and break. So they had to draw it, temper it, draw it, temper it. It was quite a process to draw out the tool steel wire, And there's only a couple places in the country where you can even get small diameter tool steel.
Where are the places you can get it, and what does it run per whatever they sell it in, pound or whatever? Not even a pound.
No, you pay by the wire.
Oh, really?
You pay by the pound. Way, way, way back, there was a company called Y-Tech Industries, and I don't know why I still remember them. It was like the first place that you could get drawn tool steel wire. And the only one I could get was 420 stainless, which is a very common mold steel. But I had to buy 10 pounds of it. So they drew 10 pounds of wire. It was 10, 15, and 20,000ths. Have you ever seen 10 pounds of 10,000ths diameter wire?
You probably still have some of that.
No. When I first looked at it, I said, I will never use this much wire in my lifetime. But I think 10 years later, it was all gone.
Jeez.
There's literally 100,000 pieces. I don't know. There's got to be. I mean, we had a tube, an inch in diameter, just packed, a foot long. I think it was a foot long, just packed with 10,000 wire, and I had 20 of them. It's like you look at that, it's like I wish I knew how many pieces we were, but nowadays, we'll spend you spend a couple dollars per piece of wire, and they're 18 inches. I think we're buying them at, but yeah, it's
who sells them today? I'm interested because if they sell them by the wire, I'm gonna have to get me a couple. And
actually, company in Rhode Island, Novatech, and what's the other one? It's begins with a D. Dynatech? No, I don't know. But Novatech is the biggest one. I actually helped the guy from Novatech, Ron Godin. He was the originator. He started Novatech. He worked for, just to back up a little bit, if you don't mind, when I started, I was a tool maker. I was coming from high school to my dad's shop as a mold maker. I was a grunt in the beginning. I was bringing stuff to the heat treaters, and I was running errands. Well, there was a guy in Rhode Island, Jimmy Donovan, from Advanced Welding in Rhode Island, and he said, you got to bring it to the welders. And this was back into the late 70s. And Jimmy Donovan was a real pioneer in micro welding. And I used to weld in high school, and you ever see those welders where they use those little wafers and you burn them and they burn off, they make oxygen? You ever hear of those? There was these weird things that I was trying in my mother's cellar. I was trying to make, a welding machine because I was just fascinated with it. But then when I thought of welding as a career, the only type of welding I knew was you see the guy completely dressed in leather, big helmet on, he's on a skyscraper or something, his head's engulfed in smoke. It's like, I don't want to do that. So, but then I started running errands for my dad's company. Oh, you got to bring this down to the welders. I go down there. It was like a clean room environment, all maple top desks, track lighting, the music's going. The guy's got a cup of coffee. He's looking under a microscope. It's just a completely different atmosphere than you thought of when you thought of welding.
Oh, yeah.
And I said, that's for me. So I was doing that for a while, and then, bringing stuff back and forth. And he took me under his wing. It was actually one Saturday. It's all I actually went down there for him to sit there and him to teach me. But he said even at that point, I was better than one of his guys that he's been training for years. And I really took to it, and I absolutely loved it. And then he had an old machine that he wasn't using anymore, and that's the big orange Airco welder I bought, and it all started from then. But and Ron Godin he wasn't a welder, but he was more of a, he scheduled the jobs, and he was doing all kinds of research on different things and that. And he ended up leaving there and starting Novatech. He needed some money, so I actually loaned him some money because we became friends, and I loaned him some money, and he started Novatech. And sadly, about 10 years ago, or maybe longer now, he passed away from pancreatic cancer. But his partner, Ralph, is still there, and they're still selling wire, small diameter wire. And so, they have all that stuff.
Definitely have to look that up.
I'm already on his page. It carries quite a bit of stuff.
Your story it reminds me kind of my story. Before I went to work for airline maintenance, my very last job before that was a shutdown on a paper mill as a pipe fitter. And so I was the guy with the head and the plume of smoke, wearing all the leathers, and standing in a puddle of black liquor, leaking crap out of some pump. It was just a nasty, nasty job. And I went straight from that into an air-conditioned shop, all TIG welding, mostly, 030 wire, 1/16 tungsten. That was like, I thought I died and went to heaven.
That's like going on vacation.
Yeah. I guess it's semi-retirement here, all this and a paycheck too, It's crazy. But I can appreciate that. It speaks to the point that, there have been efforts from the American Welding Society to try to improve the image of welding, because the image of the guy with the smut on his face and smoke and wearing leathers and pulling a trigger on a flux core gun running 500 amps, that's kind of what a lot of people think about when they think about welding. But it's so much more than that. There's so many very, very technical areas you can get into, and the tool and die and the area that you're in is so technical, because I would say that you have to know much more about metallurgy than most other welders do, doing what you do. You're talking about, even just with there must be 100 tool steels at least, and you got to know a little bit of something about how they're going to act and how they're going to react and all that.
We get tool steels come in here all the time that I've never even heard of. You get that. What happens is you get these new designers. These kids out of high school, they get a job at a mold shop or something, designing, and let's use this alloy. It's supposed to be great. Never looking into whether it's weldable or anything. We get stuff in here, sintered materials and CPM 10V and Royaloy and which is the one I just welded the other day.
Caldi?
Oh, Caldi.
Yeah.
That was another one. That's the gun frame there that I was talking about earlier. That was all made out of Caldi. And the customer had to use Caldi on it, so he bought like 5 pounds of it. It was $350, and it was 40 thousandths in diameter. Well, normally for that job, I would use 20 thousandths wire, but that's the only wire I had, so I had to use 40 thousandths diameter. I'm still waiting to see if it came out all right. I haven't heard yet.
Yeah.
But, so it's like we run into so many LMAX. That's another one that welds terrible. Another alloy that we get all the time, You
used to, you get familiar with alloys, and after a while you think you kind of know, and then you get thrown a curveball from some German alloy or some proprietary thing that some PhD in Switzerland designed or something that, you never heard of it. And, it could be very similar to something you've been doing, but then again, it could be something totally different. But you got to do your homework. Again, it goes, pulling full circle. It goes down. It speaks to the whole idea of niching down and carving yourself a niche in the industry. And if you're the guy that's willing to do the research and all that, you can really, be the go-to person for this kind of thing. And look, it seems like that's what you guys have done.
Well, a lot of, like A10, D2, and So, you know, A10, you can actually, under the scope, you can see the strain. It's a graphitic tool steel. You can see granulated graphite throughout the material. Very difficult to weld. And a lot of the biggest problem is because the tool and die industry is big overseas now, China. There's a lot of more molds are made in China now than made in the United States. And but they bring them back here to run them. They have them made in China. They ship them back to the States to run them. Now, a lot of these molds, we don't even know what kind of tool steel it is. It's not marked. Oh, it's a Chinese tool steel. That's all they tell us. Oh, it's Chinese tool steel. It's like, okay, that's great. Thank you for that. So, I mean, you know, we'll Rockwell test it. We'll copper sulfate it to see if it's stainless, you know, a type of stainless. But that's, you know, that's really all we can do. You know,
Sure.
So it's, you know, we've had tool steel cavities that had pits throughout the whole mold, throughout the whole steel. It wasn't a pure, because it was probably just a bunch of tin cans and old truck rims or something that they threw in there. You know, but you got to weld it. You know, it's like, yeah, we only got, you know, the $10,000 cavity here. You got to weld it. You know, it's like you put 3,000 degrees into this $10,000 part that they can't go down to Walmart and buy a new one. It'd take them a month to make one. And but they want it yesterday, and it's going to be perfect.
Yeah. You know, back, I guess it was, I'm not sure the exact year, but it was sometime around probably 2009, 2010. Scrap prices went so high that manhole covers were showing up missing in major cities. So you probably got some manhole covers in that man.
You know
what happened? It was, you know, some people would steal a manhole cover and take it and get scrap prices for it. That would ship overseas to China and get remelted into who knows what, and then we'd buy it back. So it's probably not too much of a stretch to say there were probably some manhole covers in what you were welding there. Yeah.
Oh my God, it's every day is a new adventure.
Yeah.
You would think nowadays that everything would be stamped with what it is. I bet you still 50% of what we get in here is just a guess of what it is. You know,
That's crazy.
Yeah, I think you don't. You know, like you said, you do a hardness test on it. You do maybe some, like you said, some chemical tests to eliminate some possibilities, and then you're kind of like, at least you got a pretty good idea how to approach it. More so than just a shot in the dark, you know. And
you can pretty much know right off the bat if it's gonna weld all right. You know, I've had alloys that I worked with, you know, TIG welding. You know, you're trying to TIG weld it, and it's just completely cracking all around the weld. And that was they had some 3M sintered, you know, powdered metal, that type of material, and there was zero elongation of the material. I mean, once the area gets welded, it takes on a completely new structure from the base metal, and it'll just separate. Pull it right around the edges. The whole thing will fall off. You know, it's like, ugh. So we never know what's going to come in the door.
Which what I really like about it is because a lot of the time, you know, you don't know what's going to come in, and that's what's exciting about it. Everything, it's always different. It's always different.
So what would you say is your favorite thing to work on?
Let's see. My favorite thing to work on? You know, I don't know. I really like positioner work just because, you know, you always try to make the next one better than the last. I mean, it can get, what's the word I should say?
Monotonous?
Monotonous, yeah, it can get monotonous. But, you know, it's kind of like, it's kind of nice, you know? I like doing stuff like that. You know, honestly, anything that you feel like you really, you know, help the customer out. Like, they need that part, and you do your best, and when it doesn't come back, you know you helped them out, and they're really happy. But
the waiting
you get that
game.
Email once in a while, you get that email. You know that part you did last week, Josh? Yeah, I think I remember. What's up? It's not coming back, right?
Because that's part of the challenges of laser welding. Because laser is not a free flowing homogeneous weld. It's almost instantaneous. and it's much more apt to crazing or surface cracks or entrapment of little air pockets. See, Josh doesn't really have the luxury that I did when I first started welding because nobody else was welding. I mean, there was nobody really around. So if you screwed something up, they were just happy to get it welded. They bring it back again. And I had the luxury to kind of learn as I went. But right now, customers are used to this level of quality. And so, it's hard to go through that learning curve without losing customers. You don't really have that luxury anymore. Like we'll weld in high-speed steel. Like I can weld high-speed steel, M2 or M42 with the TIG welding process, and it's not a problem. We can weld M2 or M42 with the TIG process, and once you start getting to a certain thickness, it'll start to crack every time. So it's completely different. The as weld, we deal with as welded rock weld too. We mix and match tool steels all the time depending on hardness. Like if a customer says, I need such and such a rock weld, well, the as welded rock weld of this type of welding wire on this type of steel isn't the rock weld they're looking for. You know what I'm saying? Like if it's a shut off area, or if it's a gate where the plastic runs through, they might want something with we'll use an H13 or an H19, not H19, H12 that has a lot of tungsten in it, or something like that for wear resistance for a gate. A gate is where the plastic comes through to fill the cavity. And so we will mix and match alloys all the time depending on where the weld is being applied to the part. If it's a shut-off area, if it's a gate, if it's an inside corner, if it's an area that it doesn't matter what rock weld it is because it's just a molding surface. It's not, you know what I mean? So
Sure.
We constantly are mixing and matching alloys. Just because the block is 420 or S7 doesn't mean that S7 or 420 is right for this area that we're welding because it's not getting reheat treated. If a lot of the stuff comes in, most of the stuff comes in is in the hardened state, already hardened, molds in production or ready to go into production. We do get molds come in that get screwed up in the machining process, so they haven't been heat treated yet. So that's when we have to be more exact of what alloy we use, because if you weld an area with H13 on a 420 block and they heat treat it thinking it's 420, that section of the H13 isn't going to heat treat the same. You know what I mean? So it's like a chemistry experiment going on all the time. What alloy are you going to use for this area? If we use this alloy, it's not going to wear right for this purpose. It could be a side action where it's seeing a lot of back and forth all the time. Two surfaces meshing together, we can cause galling, or it starts to pick up and it becomes a mess. So we're always saying, no, we got to use this type of alloy in this area, even though the block is made out of this other stuff.
Yeah.
So
I read you. You mentioned earlier about having to butter with like 300 series in some little areas, and then overlay that with the harder material, just to make it work and whatnot. So I feel you.
312. Great
yeah,
stuff.
we use a lot of 312 stainless on things like that. It's slightly magnetic. It's good stuff. 680. It's actually better than. I don't know. It's about the same as 312, but 680.
Is that a eutectic alloy?
Yeah, eutectic 680, exactly. Yeah. Really high tensile strength. And they say they don't tell you what's actually in 680.
I know. Eutectic is very, very protective over the constituents of any of their alloys. It's like, no, this is what it is. It's 680. We're not telling you what's in it.
If you like it, you like it. If you need to know what's in it, well, go somewhere else. But I've heard it's pretty much 312 stainless. So, but a simple job with the TIG may be very complicated with the laser. Like we weld over a lot of an EDM surface, which is a recast. which got that recast on it, which is the carbon being brought to the very surface. There's just so many challenges because you can't have any microscopic, tiny little speck of anything, little cracks, little pits, it'll all show up on the mold. It'll show up in the plastic. And we weld for some companies do optical polishing, all machine polished globes for like cameras and security cameras and things like that, where it's actually a flawless surface, and there'll be a dent or a thing right in the middle of it. And you talk about heat affected zones and the fisheye, they can't have that.
Yeah. So
because a fish, the heat affected zone will show up on a clear plastic part. So we're wrestling with that stuff all the time. We have all kinds of little techniques and things we do that learned over the years. But
there's a PDF that I snagged, and I have it somewhere. It floats around the internet. Sometimes I can find it, sometimes I can't. It's a guy that wrote this book. He was a tool and die guy, and he just wrote this book like almost a diary of what he had learned. And one of the main things I remembered was he was talking about a copper alloy on a mold. I'm not sure if it was beryllium copper or what alloy, but it was a certain hardness that just didn't make a copper rod that would do that. And he used 410 stainless to match the hardness.
Yeah, we'll routinely put stainless steel on copper or beryllium copper.
I thought that was like so outside the box. Like I would never automatically think of using a 410 stainless filler for copper alloy. But then again, I'm not a tooling guy, mold guy either. I've only dabbled. So it's like, let me open my mind, or let me pay attention to some of this stuff because these guys know something,
It's a lot of the gate probes that they go in, for heating the plastic. It keeps the plastic free flowing as it's going into the mold. And a lot of these gate probes are made out of copper alloy, beryllium copper, or Amcolloy 940, or something like that. But the tip has to be hard. So because the tip seals off into the gate vestige. So a lot of times in those situations, we will put like a 420 stainless or 410 stainless on the tip, because I have 410 stainless in the drawer right now. So there are a lot of mixing and matching of alloys, even ferrous and non-ferrous. Sometimes.
Again, to my point, you got to know a little bit about metallurgy to do what you do.
Yep.
I'd like to know more. I'd like to get even more into it. I'd like to take some sort of class. Do they have classes on metallurgy? I mean, they must. Right?
Oh yeah, yeah.
I'd like to get into that a little bit.
You may wind up. I'm going to go ahead and say this and get myself in hot water. You may already know more than the teacher will know of the classes that are offered.
And a lot of times it's how metallurgy applies to welding. Mm-hmm. I mean, you can learn about metallurgy, but how does it apply to welding, or how does it? It's like a doctor. You got to start getting specific. He might be a dentist, but he doesn't mean he's going to remove your gallbladder, but he's still considered a doctor. You got to fine tune and find if you're going to go to school, find something how welding applies to metallurgy. How metallurgy applies to welding, because I was talking about as welded rock, just made me think of something. Like when we got to weld D2, one of the very top 5 difficult tools to use to weld. Well, they say, you got to use D2 on it. Well, D2 tool steel only comes in a core engineered wire, where the wire is hollow, and the elements that make it D2 are in the middle like little particles. Mm-hmm. And as welded, D2 is soft. We routinely use M2 on D2 and not D2. And besides, the core engineered wire it's difficult, it's dirty, you can't get it in small diameters. So you can't even buy D2 tools. There's some wires they call it D2, but it's not D2 tool steel. So I don't know. It's just
that little spiel right there, that little thing that from experience, from hard knocks, and okay, we use M2 wire on D2 steel. Who knows that? I guarantee you, I've worked with a handful of metallurgists who were PhDs. They didn't know that. They would be lost as a ball in high weeds trying to give you advice on what filler metal to use to achieve a certain hardness on. I think that the nichiness of what you do is kind of like made you the experts, and you could bring in the best metallurgist ever, and he wouldn't be able to help you. Because honestly, they know what they know. You know what you know.
Yeah. I mean, there's just so many challenges. Like when we weld a gate, well, a gate goes, is what feeds the part with plastic, and it is parting like gates is sub gates. Like when we weld a sub gate, there's a hole in the back of the block, and the molding surface is on the other side with the little hole in it where the plastic comes through. So depending on the gate, but a lot of times we'll weld the gate from the back, meaning we can't see the front. So we have no idea and it could be a ton of detail in that. All, ribs and polished. A lot of the stuff we weld is high polished because it's part of a shiny plastic part. And in order for the plastic to be shiny, is the steel has to be shiny, or clear or whatever it is. So we're welding from the back and trying to cover the front at the same time, because it might not be an area you can go into and weld because it's deep or something, or it's inaccessible. So, it's just so much, just years and doing thousands and thousands and thousands of gates over the years, how to flow out that gate, how to add the wire, sometimes just pushing the wire, with a little forceful will actually push the molten, puddle more to the front, and then when you weld in tool steel, sometimes when you just, you bleed your arc off it, you're done, and you'll have a little spiderweb crack in the middle of the gate. So when we're welding gates like that, I tend to leave a hump. It's like the Hoover Dam. It's shaped that way for a purpose, right? Because it's stronger that way. So I'll purposely leave like a hump. I'll add wire, and I'll start to bleed off the amps, and then I'll start to actually raise the tungsten up, creating a bigger gap as I'm bleeding off the amp, just so it won't crack. It's just so many problems can be overcome with just pure technique in this industry, and it's challenge, it's a challenge every day.
I bet.
Yep.
But it's technique. It's technique learned the hard way. It's learned from ping. Oh crap! I just cracked that, so that didn't work. So what do I do different next time?
Right. There's preheat, then there's post heat. Sometimes we'll put it back on. Sometimes I'll weld something while it's on we have these little digital heaters. Sometimes I've welded something while it's on the heater, because it's so susceptible to cooling. And when you're doing micro welding on a big block of steel, it's not really staying hot.
True.
Because the heat that you're generating isn't overcoming the heat that's normally being lost. So we might weld it for a little bit, put it back on the heat, weld it a little more, put it back on the heat. We don't want to get the temperatures too high where we start to temper the steel either, because then you start to lose the hardness. The molds, tool steel can actually grow or shrink depending on things. And a lot of these mold components are part of a bigger assembly where they all, like we might have a mold that has, 50 inserts in it, or 50 cavities or cores in it that all, sandwiched together in a mold base. And you start changing the size of these blocks or distorting anything, the whole mold is going to fail. So it's just a tremendous amount of things that go into it, and I've been doing it so long that I can assess something pretty quickly and get to it. And still I get slapped in the face once in a while. It doesn't happen too often anymore, but but it can still, it's a recipe for disaster, but we have a tremendous record for what we do.
That's cool.
Cool.
So now, what is the biggest difference besides amperage between micro TIG welding and regular TIG welding? And besides the size of the weld, obviously. But
Well, actually, I was asked that in the article, in the chapter I wrote for that book. And there is no real standardized meaning of micro weld. You can Google micro welding and you'll see all kinds of different companies. But the way I determine what micro welding is welding under a microscope with wire between 3 thousandths and 20 or 25 thousandths under a microscope. It's really the TIG process kind of refined, with the welding machine itself, the type of argon we use, the shielding gas, the way the tungsten is ground, the torches we use. But basically it's just TIG welding. Basically it's just TIG welding at a much smaller scale than what normal people think, people normally think of TIG welding as.
You said something that interests me. You said the type of argon you use. Do you guys use a more pure argon for micro TIG?
Well, yeah, I've used years ago. I used welding grade argon, and it was terrible. So we were using a 4.8 purity, which is 99.99% argon, laboratory grade. And then as my company got bigger, we went to liquid argon. Use a big tank of liquid argon and use the vapors, the pressure off of that. And that's even purer than laboratory grade argon.
Mm-hmm.
And you guys have that stuff just flowing out like crazy then?
Well, the liquid tank, if you don't use it, it'll use itself.
Right.
Yep. Like right now it's Sunday and it's probably been venting all weekend, but it's not, if you get a tiny little shop and stuff, it's just not worth going to liquid argon. So, but we use it at a pretty good clip now. So I don't know, what does the tank last us? It lasts us about 4 weeks, right? I think it lasts about something like that. 4 or 5 weeks now, a big liquid tank. But if you're like a little 1-2 man shop and you're doing this, the laboratory grade argon is the way to go, because the regular welding grade argon, you'll notice a tremendous difference when you're under the scope and doing that level of TIG welding.
I was just going to ask, was that with the laser or the TIG or both?
Both. It's plumbed into my shop, and it goes to all my welding stations and the lasers. So
do you have any extra filters, like oxygen filters or CO2 filters or anything like that? In your system? Yeah, we have inline moisture filters. Mm-hmm.
To get the little like BBs in there and stuff, the canisters. We have those in line. But other than that, we don't have anything else.
Okay.
With your regular TIG welding, would you ever use that under a microscope, or is that just not small enough to even bother with a regular TIG welder with a stereoscope?
Well, we'll use a micro. Like I had an the AeroWave 300. That was the welder I've been using for years, and it's like I said earlier, we just got the Dynasty 400. But we have a scope on that station. Yeah, I'll be welding jobs with 200 amps, maybe my 300 amps, depending, maybe if it was beryllium or something. And I'll be using the scope, especially if it's a rotary positioner job, because once you start looking at a weld under a microscope, you start to see things that you don't really see with the naked eye.
I'd love to.
Things just look different. The amount of detail and things like that it's just incredible when you first start welding under a microscope.
So what kind of shade do you use on your microscope for TIG, or like the micro TIG welding?
We have a little flipper that's attached to the microscope. It's a manual one. There's they have these other ones that you can hit with your knee and the thing will flip. But I've been using it for 30 years, and it's not a big deal. The only problem sometimes is when you're trying to weld something that's very awkward, and you're using small wire, and you're trying to get the wire just into view, because you almost, you know what I mean? Because it's tiny wire, and it's sticking out of your fingers. I got the wire coming out about 2 inches. or whatever, and it's got a bend on it because I have to get it around a corner down inside of something. And sometimes a pneumatic flipper would be good for that reason. But I seem to be able to find the tungsten find its home. But I use I think it's a 9 shade right now on my welding lens. And at one time, I was actually buying the round welding lenses, sending them out to get them polished. Because here you are welding under this expensive microscope with high-quality optics, but really you end up looking through a $2 piece of glass, right?
Yeah.
So, there was a time that I was actually sending out all my welding glass, my shade glasses, the round ones, and getting them polished. But I have actually a gold-plated one I've been playing with now. That's on my station. It gives you a little different. You don't get that green look so much, more of a natural color.
Do they have auto tint lenses for those? I've seen adapters for different types of scopes just looking around, but you have to buy the whole unit.
Who knows? It probably is, but I don't have one. I've actually think I took the lens off of my what's my helmet? I get the Jackson. I got an auto darkening helmet, so I think I've taken the lens off of that, taped it underneath my microscope at one time. This is years ago to try that, but trying to put a rectangular shape into a round hole. That's because I had to tape it on. But I don't know. There's so many new things out there. It's hard to keep up with everything. But those are the little things that start evolving. The micro TIG welding is really the part that's evolved the most. Is obviously the introduction of laser. But as far as the TIG part goes, it's pretty much the same things I was using 20 years ago.
What kind of micro TIG machine do you have now?
It's a company in Weld Logic in California.
Oh.
Yep. They have the ones that'll go down on 1/10 of 1 amp.
That's insane.
Yep.
Yes.
It really is.
I seem to remember seeing they have a presence at FabTech a lot of times.
Mm-hmm.
Yeah, they're at all the shows. They're at all the shows. They have a microplasma welder that I tried years ago. I want to get back into that again and just experiment again with the plasma, because I think it might have its application. They used to have it was like an add-on machine you can put with the main welder, but I think right now it's its own separate entity. I actually looked into it a little while ago, but I'm always looking to new things and better ways of doing stuff.
Oh yeah. So Josh, I'm looking here. I'm staring at my computer screen, and I'm seeing a post on Instagram of last FabTech 23 weeks ago. That would be the last FabTech.
I was looking for you. I was looking for you.
Yeah, I didn't make my way around to the CK booth until maybe the second or third day because I just got distracted, I guess. But how did you like it?
I loved it, man.
Was that your first FabTech? And
yes, sir. Yeah, it was, and I'll tell you what, I loved it. It was great. It was like, when you're on the Instagram world and then you go there, it's like, whoa. It's like you see everyone that you follow and you're inspired by these people, and then you get to meet them. So cool. So cool.
I'm glad you said that. It is because we all, me, Roy, Jonathan, we could do FabTech once a week probably. I mean, really, it's kind of this is what we do. We're all in, and to be around like-minded people and just talking shop all day long. Because I'm looking at here, I'm still looking at the Mishler brothers and Jason Mosier, Dave Blackburn.
Yeah, we all went out actually. I didn't with the Mishler brothers, but I was with Jason and Dave Blackburn, and we went out and went to this Irish pub, and it's just funny, man. It's I don't even think me and Dave talked welding at all. I think we were just buds, man. We were
exactly,
and that's
what I find. That's what I find. Whether you're talking welding or just life or whatever, it doesn't really even matter. It's like, man, you're just like my long lost friend, and. almost everybody I meet, I feel that way about.
Yeah.
So anyway, I'm going to go back.
He's a great guy, man, Dave. I know you guys have met him, right, and stuff like that. So he's an awesome guy. Yeah.
Yep. I'm looking at Nick, Joni Butler.
Yeah.
The whole
she's
crew.
Great. Yeah, they're just so nice, man. They're just like welcoming, and I did the razor blade challenge, and I did it like right after I met everyone, and like I meet everyone, and I'm all like amped up, I'm like, wow, this is crazy. It's all coming to reality, from the internet to reality, and oh yeah, you want to do the razor blade challenge? And I'm like, yeah, sure, I'll do it, and it's like next thing you know, I got a guy in my. You're on Facebook Live, and
no pressure.
Joni's going. Yeah, Micro Arc Welders. He's the last one to go, and he's amazing. You gotta check his work out. This and that. I'm like, oh god, oh man, you're building up the prep. If you could put me in a awkward place, if I could think of the most awkward place to weld, well, not awkward, but like pressure wise or uncomfortable wise, man, that was it. That was it, man. I'll tell you what.
Look at all that.
The only time my hand shakes that much is when my uncle's staring over me. My hand was like a rattlesnake. I'm telling you, it was like, I don't even think I was looking at my puddle when I welded those razor blades. I was just freaking going. I was like, oh my god, man! Like, I'm on Facebook Live. Like, I just met every one of my idols. I almost couldn't handle it.
No. You got some heavy hitters. You got some heavy hitters there. You got Rush Kane Kid.
Oh yeah, Kane Kid. Yeah. He's amazing talent. Yeah.
I know. I think it's cool that they did that. It's a good idea for them, and it's a good idea for all of us.
I can't tell you how many times I said, "Oh, I stuck my tungsten in front of everybody. I stuck my tungsten." My girlfriend's like, "Shut up! No one cares."
Yeah.
Dude, you stuck the tungsten. Get over it.
Grow a set, she said. I know.
But it was, what? It's good to take yourself out of your comfort zone. It is, and that's what that was, and so yeah, it was awesome.
Are you going to make it to the next one?
I hope so. Yeah.
I haven't been in a few years. I've been hunting in Canada for several years, and it's always at the same time in the middle of November. But this year is going to be a little earlier, I heard. So I plan on going to this one because you learn so much at these sub-arc welding. You see this just so many additive laser spray welding, additive metal welding. It's just there's so many different things out there, and it's just it's always a great education.
It really is, and for somebody that's kind of on the cutting edge of their industry, like you guys, it's you got to stay out there and seeing the newest and greatest stuff. And I don't know where a better place to see it than there. I mean, there's other ways, but as far as a couple of day total immersion experience to see what's new, that's where I first must have been 15 years or so ago. When I was my first fab tech, seeing the benchtop lasers, they were mostly geared toward the jewelry industry, like you said, and they would give this little demo where the guy would hold these two stainless steel screws that were countersunk head, and he would just pop up, and he would just use his fingertips for a turntable and bap, 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 and then they would hand them to you at the end. They would be cool to the touch, and it was very impressive. I had no idea before that
I think I saw the same demo.
Yeah. Yeah, but I don't even remember the name of the company at all, but I do remember the demo. And then fast forward, we get a basically like a much bigger unit at Delta, because it was literally this repair development department of engineering was tasked with trying to develop repairs for parts that they would normally scrap. So they had scrap parts on the shelf that they were trying to figure out repairs for. And they had literally like, okay, you guys, you got $100,000 we got left over in the budget, so you got to spend it in 48 hours or it's just going away. So they bought this Trump YAG laser, and we started farting around with it, and that's how I got acquainted with it. But it's still all very cool stuff, and I don't know what they're doing with it now because I've been long gone from there. But it was more like a R&D machine than it was anything else. Let's figure out what we can do with this, and then we'll buy a bigger machine for the actual process. kind of a thing. But it all stems from FabTech, seeing those demos there. That's what's so awesome about FabTech is in a few days you can just see so much.
Yeah.
Oh yeah, you can. It's the whole industry crammed into one building.
Mm-hmm. Crammed. Yeah.
Crammed. Yeah. Crammed.
When I go, I try to cram as much stimulation into my brain as I can, so my feet are just like dead at the end of each day. I'm walking, I'm trying to see everything I can see, and you can't do it in a day.
No
yeah.
way.
You can have a little fun with some of the demo guys too. They'll have the salesman doing one of the lasers, and you could sit down and say, "Hey, can I try that? I've always wanted to try one of these things." And you sit down and just like lay a perfect bead on it, and it's like, you done this before? Nope, never.
First time.
Mm-hmm. Beginner's luck. See ya.
Yep.
First time.
Who was that guy?
I'd like to send you guys a picture of something. Maybe maybe not right this moment, but it's a little guy I made out of weld. I TIG welded it back when I first got my first micro TIG welding machine, and I got set up. It's probably about a quarter of the length of my fingertip, and it's a little man that I made with 5,000s wire. I think you guys get a kick out of it. I'll maybe later on I'll get some phone numbers or something and send it to one of you guys.
I
think you'd be interested to see it.
I would. I know that. We've all messed around with stuff like that, but not on that scale. I've messed around with it just with like a Dynasty 200 with a 1 amp start, not a 1/10 of an amp start, But, it's cool stuff when you talk about, shrinking things down to that scale. That's just, I think it gets everybody's attention.
Oh, yeah.
Yeah. Biggest thing too is dealing with distortion, because tool mold components and stuff cannot deal with distortion. So you got to control it. You can't let it control you. So there's all kinds of things we do for distortion control. But
communication is key between the customer as well. It's one of those things, you gotta have perfect communication between the customer and what you're doing, because
most of our customers are out of state. And there's people I've actually talked to for 20 years I've never seen, because they're in Arizona or someplace. And so, and I tell this to Josh all the time, there's no such thing as a dumb question. If you're not absolutely positive about something, we find out. And if you see, part could come in and with some damage on it or something that needs to be fixed, but you see other damage in other places. You go, well, they didn't say anything about this, so I guess I don't have to weld it. Get on the phone and point it out to them, because the last thing they want to do, a company from California or out of state, Arizona somewhere, ships you a part, you weld it, you ship it back, and they go, oh, we had these other spots that we didn't see. Now they got to ship it back again for a little dot of weld. It's like, that's where communication is real important.
Customer might think it's a crack and a scratch, and it's really a crack, because they're not necessarily looking at it under a scope,
or the other way around.
Yeah,
we've had a lot of things that say, oh, this part's cracked. They look at it on the microscope. Nope, it's just a scratch.
So, we've had this conversation before on here on this podcast about communication with customers, and it is key. It can solve so many problems. And in this age we live in, texting and email, there seems to be a big reluctance to pick up a phone, and call and actually talk to a person on the other end. But no substitute for that sometimes.
Yep, you got to do it, because there'll be a lot of technical stuff. We'll get big blueprints with for a pretty technical part, and and a lot of times we have to kind of decipher what the customer's trying to do, because they're not communicating well with it. But being in the tool and die industry, we know how to read blueprints and all that kind of stuff. So sometimes it's a lot of back and forth, but now you're getting a lot of people that send the 3D modeling. You can actually take the part and twirl it around on your screen and cross-section it, and we're getting I wouldn't say so much with the tool and die, because it's really not that important with the tool and die, but with doing, micro weldments and stuff, for, medical device manufacturers and, stuff like that, prototype work, and it's really beneficial when you can have that type of technology to really understand what the customer's trying to do.
Mm-hmm.
That part of it is really fantastic.
Well, what kind of advice would you give somebody maybe wanting to break into, not even necessarily tool and die and stuff that you guys do, but just, striking out on your own in a small business, welding type business?
Well, there's no, like my father always said, there's no substitute for hard work. And he was a guy that worked 7 days a week in the mold shop. He was a pioneer in the mold making industry. Real pioneer. He made the first, the Polaroid one-step cameras, the Polaroid Instamatic cameras with the picture came out. He made the first mold for that camera. He made that first camera. And the little tags, you get on clothes that you got to chew off to try to get the tag off. So it's called a Swift Attach. My dad made the first Swift Attach mold. And I used to make the Swift Attach molds back when I was a mold maker. Very, very technical mold. But with any business, you have to give it 110%. There's no such thing as going home at 5 o'clock every day. Some days you can, but you got to be willing to stay as long as you have to, and just do perfect work. Be your own worst critic. You got to be your own worst critic. You have to look at your part and always find something wrong with it, really. Even though it's perfect, you say, that part could have been better. Because the minute you say, it's perfect, you've already lost. Because nothing is perfect. You just got to really be a perfectionist in this type of business and learn everything you can learn and just never quit. You can't quit.
Yeah. You mentioned way earlier in the podcast, and I want to make sure everybody understands when you're talking about 7/10. You're talking about a tolerance of 7/10 of a thousandths.
7/10 of a thousandth, yes.
Exactly. I want to let that simmer a little while. Let that sink in, everybody.
0.0007.
Mm-hmm. That's a lot of what I used to do. In like pipe fitting and all that. We're talking about eighths and sixteenths and 30 seconds. Not 7/10 of a thousand. So it's a different world, and that's why you use microscopes, and that's why you use lasers, and that's why you use microtig that starts at 1/10 of an amp. This is a precision world.
Because you might not be welding with 1/10 of an amp, but you can't strike an arc where you're instantly melting the steel,
right?
Because you're already destroyed something. We've got on this metal. It was electrical connector mold, and these little towers that are literally 20,000 square and probably a 1/16 of an inch tall. And I had to weld the sides of them or certain areas on them. And you can't start off, melting the steel. Sometimes we'll actually start the arc on something else and then carry it over. Because sometimes you're welding down in between these little clusters of little tiny, mold core outs, literally 20, 30, 40,000 square, and you might have to weld down between them without arcing out on anything. You can't have arc wander. Just arc wander will melt all the tops of all the things over. And the customer will, what'd you do to my mold? So it's like this, we'll change tungsten after every light sometimes.
I can understand that. I dealt with the Dynasty 200 in its early stages, and it's a great machine, don't get me wrong, but they advertised a 1 amp start, but they had some arc starting issues for a while, and maybe 9 out of 10 arcs were a good crisp start at 1 amp, but then that 10th one would be like it would do something funky, it would just like wander all over the place. And then you definitely had to change tips because it was all frosted up and it wouldn't start the same every time. And who knows what was going on there, but I totally feel you on that whole thing. And if it takes reprepping for every start, it's worth it.
And sometimes I'll actually set the tungsten, which I'll strike an arc on a piece of copper or something, increase the amps to maybe 30 or 40 or 50 amps, burn off any, moisture that might be in the tungsten, bring it back down, and then start on the area where I'm going to weld. Sometimes I'll do that.
Man, these are details that I just feel like we need to let that sink in for just a minute. So moisture in the tungsten. I mean, the same. I'm right with you, because I always felt like, there's benefit to lighten up on a clean piece of copper and bringing it up to a certain level, letting anything that's on that electrode, any foreign matter, any hydrocarbons or anything from any acetone or mineral spirits that were on a part, they get smoked off. Then you let it cool, and it cools under an argon atmosphere. Now that's a good surface to get a good crisp start on after you kind of like do a burn off pass, on some clean copper on it. That's an important point.
Right, and certain machines have a capacitor discharge arc start in lieu of a high frequency arc start. Mm-hmm. It's a whole different way the arc starts, and a lot of times I'll just scratch start, and because I can't deal with the high frequency wandering around, on fine details. You start melting little corners and things that even a tiny little melted corner on a mold component is a big deal, because you just can't. You're not going to go in with a file and take it off. It has to be precision machined off, and then either EDM'd or milled or ground off precisely. You might be involving some type of mold texture, and now all the texture's screwed up. It's crazy. I mean, I used to do this technique. I called it the magic bead, where we had to weld. Say we had to weld a parting line on a mold where it had a specific texture on it, a specific pattern, but they couldn't. A corner obviously involves more than one surface, so I used to weld, and say you had a parting line edge that was flashing, the edge was worn down or was damaged. I could weld that TIG bead on the very top of the edge, just wicking the weld, just touching the damaged area without actually going into the textured molded surface. So when they ground the top off, there would be little or almost nothing into the other area. I really want to show Josh this technique. It's really, really fine. You have to have a bead that's a tall, thin bead to do it. If you have a wider bead, it'll actually can pull the edge back and make the situation worse. You have to just plop the weld right on the edge and carry that across without flowing that wire down at all into the molding surface. So there's just so many things and techniques that we had to learn over the years to solve problems.
Yeah, absolutely.
Yep.
Sounds like fun.
Well, that's the thing with the tool and die industry. Occasionally we'll get, a 64 cavity mold, and all the parts have to, are all the same welding. But normally it's onesies, twosies, four of this, 6 of that, 2 of this, 1 of that, and it's always different from every day. Like when we used to weld a lot of syringe molds, where you have, for the medical industry. And you get the inside of the syringe is very smooth, and there's a high polished core that goes in the center of that. And then the core is on a stripper plate. So when the stripper plate drops, it shears, it takes the plastic off. It doesn't use ejection pins and all that. It's a stripper plate. So that stripper, the angle where it seals off sometimes gets worn because the plastic is molded right onto that edge. So all the shutoffs need to be welded on the syringe mold. Well, when you start TIG welding this is before laser, when you start TIG welding these shutoffs, when you get done, the core is running out 30 thousandths. Well, every one of those cores has to run within 1,000th tolerance. You turn it on something. You have an indicator on it, and you got to turn it. We spent more time straightening we straighten with heat, and we straighten with peening, micro peening, and we had to straighten, every one of them cores to run within 1/2 to 1,000th run out. If you don't, the core will be a little crooked, and the plastic will be thin on one side and thicker on the other. So these are just some of the challenges that we face every day in this type of industry.
For the listeners that might not know what peening is, can you give just a real quick rundown of how all that works?
All right. Peening is, I was taught peening by my father. They used to make all their own mold bases, which is just picture a big plate of steel, 2 inches thick, 2 feet by 3 feet, or just they're all different sizes. But sometimes they would come back from the heat treaters, and these plates have to be perfectly flat. You might not be able to grind it flat because you got leader pins and things in the corners and interlocks and all that. So the plate has to be flat. So by peening, you find out where it's rocking, And we made this custom-made peening hammer with a carbide chisel point on it. And by hitting the steel, you're making a little dent in it, and that dent is actually forcing the material to the sides. And you do thousands of these little dents, and you will actually can flatten out a big plate. So when we do it in the welding business, I use a carbide peen with a round nose. I have a pneumatic one, and I also have a manual one for bigger peening. And it's a piece of carbide that's ground down with a special certain shape on it in a round end. And I just, with a hammer and the peen, I'll counteract the pulling action of the weld, because the weld wants to contract, the peening wants to push it back to where it was. So we do a lot with that. But you got to be very careful with tool steel. When you're peening tool steel, you can crack it, you can break it, so it has to be hot. There's certain criteria that you have to follow, or you can make things worse. But that's part of the distortion management that we use is peening. Peening the metal. It makes look. When you're peening your weld, all that weld is going to be taken off, so it doesn't matter as long as you don't peen deeper than the finished machine surface. So we'll actually peen things straight. So it's a lot more than, this business is a lot more than just welding. It's solving problems and using a lot of other techniques.
Interesting.
Yep.
It's interesting.
I feel like that might be a good stopping point right there.
Yeah.
Yeah. Well, I want to thank you guys for all of your experience and sharing with us, and it was a lot of fun. Definitely learned quite a bit, and makes me want to definitely learn a lot more.
Yeah, really.
That's kind of one of the cool things about doing these podcasts. I think we can all say the same thing. We all learn a lot with each podcast, and especially when we have guests on like you guys that have a very specific, niche skill set. And you guys are the perfect example of that, where you are doing just such specific things and welding on tool steels, different tool steels, and mixing and matching filler metals and knowing how that reacts and knowing how to, use certain filler metals to prevent cracking. And it's just pretty cool to hear all that. And, to relate to the average listener, it's just kind of like, just be all in, learn all you can. And if you want to start your own business, carve your own niche. That's the way to do it.
Yeah. Niches are great, but a lot of time niches, it's hard to grow sometimes a business when it's such a high skill level to do. But it's great. It worked well for me, and I still come in every day, and I enjoy doing it after 30 years. So
that's saying a whole lot right there. One little sentence. I still enjoy coming in every day after 30 years, because so many people can't say that. So many people are like, I want to just stick a screwdriver in my eyeball, No,
because if you're gonna be, work under a microscope and you literally sit on that bench for hours and hours every day doing this detailed little work. I mean, you got to love it. I mean, you can know more about welding than anybody else, but if you don't enjoy it or you don't have a rock steady hand, I mean, you need a rock steady hand to hold those type of tungsten gaps. You know, you're just not going to be successful. You got to be that type of person that just loves that stuff. Like when I get out of work, I'm on my tractor, I'm cutting wood because I'm not going to I'm not painting pictures or anything when I so you know, that's, you know, good release for me to unwind after work, do other things that are completely opposite of what I do here at work. But you can be successful. You just got to love it. You absolutely got to love it.
I hear you.
Mm-hmm.
Would you guys like to, state your business name and any, contact information in case, this might be an opportunity to, sounds like you got plenty of business coming through the door.
Yeah, but, you always, Coca-Cola and Pepsi still have tons of business, but you still see them advertising all the time, don't you?
True. So feel free at this time to, provide any contact information you'd like for whoever is listening to this that will relay that information to maybe somebody important one day.
Yeah, it's Micro Arc Welding, MICROARC Welding Service Incorporated. Our website is microarcwelding.com. We're in Worcester, Massachusetts, and what else? I think that's it.
I don't know. I think I might cryo freeze your brain though, because I'm gonna need this stuff too later on in life. You got a lot up there. I don't know, man.
We got a training scope now that that definitely helps. Because it's like you can't show anybody what you're doing. Somebody gets sitting there with a helmet on, and it's so small you can't see what they're doing. So we got a training scope now that we can sit side by side and go through things. So,
cool.
But it's just people usually don't get good at it right off the bat. It's just you get patient. It takes a lot of time.
Mm-hmm.
Big thing. You got to love it. But yeah, the Micro Arc Welding Incorporated, 33 Pullman Street, and service microarcwelding.com is our email.
Yeah. But yeah, for the people out there listening, if you like the podcast, support it. These guys are working their butts off, and they're doing this just to do it, for your benefit. And, they're selling stickers, other things to support the show. If you like it, support it.
Yeah, and guys, I have to say I am immensely impressed with what you guys do and the talents you guys have. I mean, we do some big stuff, but we're not big fabricators here. We do some pipe stuff for, oil and gas industries and stuff, but it's not a huge part of our business. But when I watch what you guys do, it's like those beads are so beautiful. It's like you guys impress me. I'm not easily impressed.
Well, thanks.
If I could only weld aluminum.
Everybody's got their own. Everybody's got their own thing, and that's why we all get together and can all benefit from everybody else's little, skill set. And that's why we love doing this. It's just cool. You're doing a certain thing, and we're each doing our thing, and nobody's necessarily better than the other. It's just we're different.
Totally.
Yeah, very cool to get together and talk. Definitely.
Absolutely, it was a real pleasure, and I'm just happy to talk to you guys.
Well, you brought a lot of value. I think anybody that has any inkling of doing tool and die repair or getting into that whole field and that whole niche, there's a lot of information here for them to chew on. That's what we wanted to do, and that's why we wanted to bring you into this podcast. And I just want to thank you for being an open book and sharing all that information.
Well, we'd like to once again thank our patrons over on Patreon.com. This month, we'd like to once again thank House of Chop, Scott Silva, Dave Horvath, Jacob Elder, Rick Alato, and Steve Funk. If you'd like to help support the podcast, head on over to patreon.com/Welding Tips and Tricks Podcast, and we really appreciate the support that's given by everybody over there.
And if you'd like to reach us here at the podcast, our email address is weldingtipsandtrickspodcast@gmail.com, and our phone number is 915-308-7024. I'm Roy Crumrine.
I'm Jody Collier.
I'm Jonathan Lewis.
I'm Josh Himmer. My Instagram account is MicroArc and thanks for having me on the show.
Hi, this is Scott Malcasian, owner of MicroArc Welding. That's a wrap.
And that's a wrap.